this is Mario here, and on this video I'll be showing you a little bit about animation with JavaScript, and the use of request animation frame, and its difference with set timeout and set interval. To do so, we will be working on this chessboard and the pieces animations that you can see working here. As you can see, there is a source square and a destination square. There is a little trick in here, and is that pieces cannot live outside squares. So when we want to animate something, what I'm really doing is that I'm creating a fake piece, which is only a div with the image of the piece that I want to animate, and that div is absolutely positioned from this top corner here. So when I want to animate something, what's really going on is that the real piece is already at the destination square, but it's hidden. Then the fake piece is positioned at the source square, and then it's animated to the destination square. Once the animation is completed, the fake piece is removed and the real piece is shown, and when we put all that together, we get the illusion of movement, and you can see the difference between the fake piece and the real one. To create these animations from source to destination, what we're really doing is that we are moving the fake piece a little bit every time. And to do so, we are using a little bit of math that I'm going to show you here, but don't get scared because it's something very simple. Let's suppose that we want to change something from a beginning position to an end position, and we want that transformation to take some amount of time. For example, let's suppose that we want to move something from 10 pixels to 90 pixels, and we want this whole animation to take 5000 milliseconds. Now there is something that we need to know. What would be the position of the object that we are animating after some given time? For example, 100 milliseconds, 200, 300, 500, 1000. What would be the position of this object for any given time? Here we have the formula. For a total time, which for this case is 5000 milliseconds, any given time, this time is going to be changing from 100, 200, 300, and a beginning, which is 10, an end, which is 90. So this formula is going to give us the position of the object for any given time. As they are proportional, we can use a rule of 3. The object is already at 10, and we need to move it to 90, which means that we will have to move it by 80 pixels. 80 pixels is to 5000 milliseconds, the same as the position P is to the time T, any time T that we want to know. Now we move T to the other side of the equation, and we are given this. And this is going to tell us how much of these 80 pixels the object has moved for any given time. But remember that the object was already at 10 pixels, so we have to include that, and the formula is like this. And just rearranging it a little bit, we are taking to the final form that we are going to use on the exercise. Remember that I told you that we will be moving the object a little bit every time. Now we will call each of these bits a frame. And that's all the theory that we need. Now we can jump to see some code. Let's talk about request animation frame. When we call that, we are letting the browser know that we want to change something on a screen, or that we are ready to draw something or to move something, and we are asking the browser when is the proper time to do so. When that time comes, the browser is going to call the callback function that you gave to it, and to that function is going to pass a single argument that would be the time, the millisecond on which that frame would be executed. And it's very important because with that time we can control the elapsed time that we talked before. Now let's see it in action. Here we have declared a variable start that it's going to hold the time on which the first frame of our animation was executed, and a variable time, which is the total time that our animation is going to take. It's a very short animation with only 150 milliseconds. And here we are declaring the callback function that we're going to pass to request animation frame. And here we see that the function is taking as an argument the time on which the frame that we requested was executed. If we move a little bit up for a moment, we will find here that we have beginning and ending positions for X and Y. Don't mind too much about this code because it's related to the board itself, but it's enough to know that we have beginning and ending positions for both. And then the first time that a step is called, start is going to be null, so it's going to be assigned with the time on which the first frame was drawn. Elapsed is going to be 0, progress is going to be 0, current X and current Y will be at the beginning, and here you can see that we are using the formulas that we defined here exactly to find out which position we should give to the object that we are animating based on the elapsed time. So we move the object to that position, and here we see that if the elapsed time from the beginning of the animation is less than the time that we want, so we request the browser to draw another frame for this animation. Otherwise, we hide the fake piece and the animation is ended. And here we have the first call to step. Step is a little bit or kind of a recursive function because it gets called by itself again, not directly, but it calls a request animation frame, which in turn calls step again. But we should stop calling request animation frames at some point. That's why we need this condition here to stop the recursion, otherwise the animation would never end. The second time that we called step, or that step is called by the browser, we have something on start, so it's not going to be touched anymore, and elapsed is going to move a little bit, progress is going to move a little bit, current X and Y are going to move a little bit, the position is going to change a tiny bit, and a request animation frame is going to be called again, and so we will be moving forward along this line until we reach the end, and the end is going to be when the animation has run for the time that we want it. At that point, the animation is going to end. And this is pretty much it. This is how easily we can work with request animation frame. It's a good practice to call request animation frame the first time outside, and the next one to call it from the callback function itself. In that way, we are making sure that we are requesting a frame after the frame before that was completed. It's not a good practice to be calling request animation frame in a cycle, for example. And what about the other functions like set timeout and set interval? Well, it's possible to use them to make animations, but it's not the recommended way for several reasons. One of them is that with those we would have to manually control how often to draw something, and with request animation frame we are letting the browser decide the best time according to the resources that it has at hand. So by doing it manually, we are forcing it to draw something that maybe it's not ready to draw, or it doesn't want, or it can't draw at that time, but we are forcing it. But with request animation frame, we're asking the browser when it's going to be the best time to do so. And as JavaScript is single-threaded, set timeout and set interval are not guaranteed to be called at the exact time that we are requesting. They could be called a little bit sooner or a little bit later, and the animation would not be as smooth as possible, or as smooth as it would be with request animation frame. So that's why whenever it's possible, or unless that there is a big reason to stay away request animation frame is the recommended way. I hope that this video was useful to you, and let's see you the next time.